ואי אפשר לעשות את זה עם שלט?
יפה.
למה הוא פליקרים?
I don't know. Because it's a bad cable. Tov, I think we're better off now than we are any other way. So I was talking to Rena before. Well, first of all, we're going to learn about distributed applications with Perl and Gearman, and I am Isaac. Hello. It's even worse? I could steal the cable from the...
disconnect and then connect again. This cable thing. No, I meant the cable.
No, I was thinking maybe it's a problem with the VGA out and not with the cable. I could steal the cable from here. We won't tell them, right? אין כזה דבר קצר מדי. I'll just stand over here. Touchy. It's still flickering. Wait a second. This new It's Good consulting business is mindset, and mindset involves relaxing. And I don't know about you guys, but with all the flickering, and are we going to have I need it. So I invite you guys to join with me for about 60 seconds. We'll just breathe in and out a few times. I'm serious. You'll absorb stuff better. All right. So everyone, close your eyes. If you think it's kooky, just watch me closing my eyes and breathe in. Breathe out. Breathe in deeper. Breathe out. One last time. Breathe in. And breathe out. All right. Now we're focused. I'm focused. So Gearman is about distributed applications. Why do we want to do distributed? So there are a bunch of reasons. Flickering again, I'm sorry. There are a bunch of reasons. The biggest thing is horizontal scaling of compute nodes. You can add more CPU, you could add more RAM, you could add more disk, you could add more hardware or software, things that you need more of and you can't vertically scale. And Gearman will make that just really easy. True asynchronous processing. A lot of times, I'll tell you guys a story. When I first met Gearman, I actually wrote my own solution instead of Gearman. Gearman was kind of in its infancy. This was about 6 years ago. And I was working with a web application, and this web application needed to talk to another web application, SOAP or XML, whatever it happened to be then. And the problem was that this was running on like a super optimized front-end server. This server that was getting like two servers getting in total, I think, 600 concurrent requests. And this one call that we had to do this other server would take like 2 minutes. So, you get 50 people doing this at one time, and bam, a quarter of your server is just doing nothing. And if you do stuff with Gearman, it gives you an asynchronous model for, next bullet point, whatever language you happen to be working in. So you can have a client in PHP and a server and a worker in Perl, or a client in Perl and a worker in JavaScript, or a worker. The list goes on. You could mix and match your languages. And there's this great design pattern inside Gearman where you could actually have nested workers, which I'll explain what a worker is in a bit. So if you have different bits of code that work well in different languages, or you're forced to use the language, or the languages have better constructs, it's a really easy way to mix and mesh languages to suit your needs. And you could also get redundant application availability, because you now have a lot of, like with thin clients hardware, you have a lot of thin clients that don't really need to do anything, and you could just scale up the back of it, and no one really knows that. Or cluster of servers. And the way clustering in Gearman works is that basically just everyone tries to connect to the first one and either ask it for jobs or tell it what you can do. So it's really not high availability in the way that you might expect, 100% uptime, active kind of setup. But it's pretty good. And I'll leave it at that. It's pretty good. And then you have a worker pool, and a worker is the function or whatever that's actually going to be done. And the way it works is you just bring up these daemons that have workers inside of it, and these workers just connect to the Gearman server, the first one that it finds up, and says, "Hello, my name is this. This is what I know how to do." And then Gearman will just send work when the work comes. So let's take some example of why you might need this. So first example is video processing. So in any of these websites, what happens? The user comes, they upload a video, and the server has to crunch the video. First it has to scan the video, make sure it's okay. Then it has to crunch the video, turn it into its own proprietary, possibly format, or whatever format it wants to go to. Or sometimes, like with YouTube, it'll actually have to crunch it into about 7 different formats at different bit rates and different quality settings. And then let's say, it'll take 3 or 4, if anyone's ever uploaded to YouTube, so you get to pick which, you have all 3 frames that it randomly picks that you get to choose what's your title frame. But something's going through it and extracting those images. And then, with YouTube, for example, I'm pretty sure they don't do some on the fly, but you have closed captions. If you could ever just turn it on, like every video on YouTube a few years ago, just suddenly magically has closed captions. So I don't know if I could be as smart and fast as Google and do it, on the fly. But let's say I want to do it when they upload. So I'm going to run some speech to text and figure out the closed captions. And then once all of that happens, I could give a response back to the user and say, okay, your video is up. This is your page, etc. Now, if I want to do this all on one machine, that means that machine is really going to be grinding for the whatever amount of time that it takes to process the image. And if I'm running on a really fast 64 core machine, once I have 64 uploads going on, I'm stuck and I can't do anything else. So with Gearman, you can actually just put it all, let's say, on an NFS store. Okay, and then once the upload comes, the web server just starts saying, okay, I need you guys to do these jobs, and you can do the jobs in parallel. Like in parallel, you can be doing the 3 of these things, etc. And then when the server is doing other stuff in the meantime, and it just gets a message back, okay, everything's done, and it could spit that out. Another example is MapReduce. So if you have a massive search engine that needs to take the search and run it against each shard of the index. You could do that on one server, and you could go again according to the whole index, or you could shard it, and then you could give the individual worker nodes a little bit of the index that they should look up. And when they're all done, they return the results, and then the master process combines them, sends them out to the client. A third example, an antivirus scam, and this is actually something that I did at my recent place of work. Has anyone seen the website VirusTotal? Yeah. So VirusTotal, what happens? You upload a file, it sends it to about 70 antivirus engines, and it gives you the results. So I had to do this project internally at a company for various reasons which we won't go into. And I actually did it with Gearman. I had a whole set of nodes running Windows. Every version, every Windows had its own antivirus client, and we knew what was where. And we'd send a job, and we'd split it. We'd send one to each type of client. We had 20 clients. We know what clients are running. We say, okay, someone scan Norton, scan McAfee, scan Clamev, and then whoever happened to be free and running that antivirus would pick it up, scan it, and return the results. So Gearman performance stats, how well does it run? We got lucky, I got lucky. And a few weeks ago on the Gearman development list, someone asked this question, not me, and we got a whole bunch of results. So deal news came, they said they have 40 foreground tasks a second. We'll see what foreground tasks are in a bit. Working across 2 data centers and 4 servers each, running 350 workers. Etsy, 1,000 tasks a second, also split between 2 data centers. And 40 workers total. Shazam, 10,000 tasks a second. They didn't say how many servers or how many workers. And then from my own experience doing this antivirus stuff, I had 30 tasks a second running, being queued by the server in 1 data center and about 240 workers processing those requests. So Gearman and Perl, because we're a Perl group. What options do we have? There are two modules on CPAN that I like, and then a whole bunch of others that I haven't used, so I won't comment on them. Gearman and Gearman Server, which is a pure Perl implementation of, both of them are pure Perl implementations. Gearman covers the client and the worker, and Gearman Server is actually a pure Perl Gearman server, because normally you'd use Gearman running as a C daemon on the server. Gearman XS is the official wrapper to libgearman, the C library. And you have any event and any event Gearman client, which are 2 completely separate distributions. If I'm not mistaken, there's also a Poe distribution for Gearman for people who like using Poe and Poe's event group. None of them are 100% up to date. None of them are 100% feature compatible. When I worked with them a year and a half ago, I patched both of these first 2. But they're pretty good. They cover 90% of what you might want to do with Gearman, and you can hack around the rest. You're Perl hackers. You can do it anything. Gearman in other languages, we'll touch it really fast. C++, you're the official libgearman. PHP. If you're not allergic to PHP, and you actually have to use PHP at your place of work, Gearman Manager is really well. I've never personally used it, but the maintainer, Brian Moon, is very active on the list, and he's always keeping it. It's like the only real framework around Gearman that I know of that's really, really robust. And if you want the not as robust stuff with PHP, you have a PECL extension and a pure PHP extension. There's a client and I believe a worker extension for Node.js. There's one for .NET and C#, also, which I had to patch a year ago. So don't count on it being up to date. Java, people keep asking about it on the list. I know it exists. It's about all I know. Python. UDFs, that's really cool. People here know UDFs. So you can, for those that don't, you could actually set up MySQL or Drizzle inline in a SQL statement to act as a Gearman client, go out and fetch some data, and actually use it inside the statement. It's a user-defined function, so just like sum or concat or trim or anything else you could do in SQL. So if you're doing something very, very database-oriented, it could be really, really cool and helpful. And you could write your own because it's a binary protocol, well published, and you can implement it any way you want. It's not so hard. This server, the returned a success packet with hello data, which is not the same as a data packet. It's not a success and a data. It's a success which has data in it, just like a data has data in it. And then you have the warning packet. I've never actually used the warning packet. It's supposed to be kind of like data, but like as a guide that something might be going wrong. But hey, it's a protocol. I mean, if it makes your project easier, use it. Is that ever? No, I didn't do fail. And fail stops the job and says, I can't do it. Something went wrong. And that won't requeue or anything. That says it's failed. It's up to the client to do something else. Exception also ends it. Again, that's one of the reasons that it has the asterisk is because it isn't really that compatible with a lot of clients, and so I've never used it. It's supposed to have like a different magical meaning, shared meaning between the client and worker. Gearman relies heavily on the fact that it's just a protocol, and the two endpoints have to kind of understand what to expect from one another. So you can make one handler for an exception and another handler for a failure, and then based on what comes back, you could say, oh, let's say fail could be a soft fail, and exception could be, oh crap, something broke in the worker because of what I did. It's really up to the user, I guess, to decide what should be in each one. So a more sophisticated worker. So this time we're going to look at the Gearman XS, and we're going to do some other cool things. Like let's start. The beginning looks kind of the same. We use Gearman XS worker. We also bring in constants, which is the gear. Basically, we only use we use a few here. So I'll shut up. We get a return value after everything in the XS version because it's really just a wrapper around C, and C likes returning stuff as return values to say if something worked or something didn't work. So first thing we do is we add a server, localhost. We check if we got anything other than success back from that. And if so, we return whatever error we got back, and we exit. And this is all, obviously, as an XS, this is really a wrapper, so that error is coming from CLAN somewhere in the Gearman object, the Gearman client object. One thing to mention is that add server, I'm pretty sure this applies also in the previous one, add server doesn't actually connect or do anything. It just instantiates, some member of the underlying class saying, this is my server. But until you actually do something with that worker, there's no communication whatsoever.
Starting a transaction?
No.
No.
There's no transaction. A transactional thing, if you want to use transactions.
Commit. I can start a transaction, but I'm not committing.
So the way I've kind of visualized transactions when I've worked with Gearman is a function is a transaction. And then I have data which can tell me, oh, I've done this, I've done this, I've done this. And at the end, it's going to either give me a success, which is commit, or failed, which is not. And obviously, from the worker side, that doesn't mean you're actually doing atomic stuff. But from the client side, you're kind of telling them the progress, and you're telling them either it's been committed or it's failed. And there's another use for the failed and exception. You could do failed, failed, okay, but and everything's rolled back clearly, or exception. Now something's inconsistent, go. Alert someone. And then we add options here. In this case, we're going to run it in non-blocking mode. So we're going to actually have in the last one we just used wait, which kind of we lost control of our Perl program from there on. So this time we're going to see on the next slide that I actually wrote the event loop. So we're going to run in non-blocking mode, and we're going to have a 500 millisecond timeout for I/O from the server. So if nothing happens between the client and the server in 500 milliseconds, it'll put me back into Perl land so that I could do something. The non-blocking mode, you also don't have to worry about sleeping or anything, because you're going to be yielding the CPU while it's waiting for I/O during those 500 milliseconds. So you can make a tight loop around that, and you don't really have to worry about the CPU going into some crazy spiraling thing. Okay, so we're going to add two functions this time. I made a function called hello and a function called uh-oh. We're going to see both of those functions on the next page. The second argument to add function here is a timeout, this time in seconds. This is the worker advising the server how long it should run under normal conditions, because in Gearman, when workers come and workers go, and that's the beautiful part of this, how scalable it is. You also want a way of letting the server realize, oh, maybe someone pulled the plug or something happened and I should be worried. The third argument is, again, a reference to the subroutine. And then the fourth option, which I haven't really made any example of here, is extra arguments that you want. And then, again, I could have done this ret equals Gearman success on every single line. I didn't really want to push that too far. And then we're going to set go to 1. to get ready for our loop. And we're going to set I hope people understand the next line. We're setting up a signal handler in Perl. We're saying when you get sig term, which is usually Control-C or whatever on your operating system, this is what I want you to do, because I didn't want a Control-C to really kill me. I want Control-C. I want to know when I get an interrupt, and then I'm going to gracefully shut my own program down. So when I get Control-C, I set that nice go to 0. And then while I have my loop here, I didn't use go here. I didn't actually check for go.
Why?
I'll have to. There you go, while go. Thank you. Like, really? Did I do such a bad job? So while go, we work. The work will return either when something happens, or after 500 milliseconds, it'll send me either IO wait or no jobs to let me know that there's nothing that I really need to do. And then if I get any other packet, then it's an error, and I'm going to print the error, and I'm going to keep going. And then wait's going to tell the server that it's getting ready to go into another cycle, and it goes on and on and on and on and on. So here are the two workers. We have hello, which does basically the same thing, plus some magic status packets. So here we get the first argument, and then we're going to send two statuses. We're going to send status 1 out of 2, and then we're going to compute what we want to do, because obviously it would look really sucky if I just send status 1 out of 2, 2 out of 3, and do something in the middle. So I computed the string hello world or hello whatever in the middle. Then we send status 2 out of 2 and return the string. And in we're going to send a warning, because you probably don't want to be here. And then we're going to send a data packet, because we've made it this far and we've seen data, and I really have to give some example of what a data packet looks like. And then we're going to send fail. So we've covered the 4 packets that even 5. We've even covered warning that I mentioned on the slide before. Okay. So first we're going to test this in Gearman. So Gearman's command line client, we could see what it does with the status, with the numerator, denominator stuff. It converts them into nice percentages. I've never actually tested what would happen if I sent it, 11.9 instead of the other way around. And then it returns success with our hello world, which is pretty much what we wanted. But realized that if I didn't know that 50% complete was coming from Gearman, like there's no visible way of realizing that's a status packet. And the next one, we sent the warning, and I didn't send a new line afterwards. So then it also sent the workload, which is world. And then it just sent back job failed, which is the fail packet. So notice also here, there's no distinction between the data packet, the warning packet, the data and the warning packet, right? And the job failed is obviously the field packet. If I'd have sent success here, if I'd have sent the hello world after the warning and the data, it would have just printed hello world again. And then once again, I might not necessarily realize which data came from what using the command line packet, the command line. Okay, so let's make a client for this in Perl. We're going to make X's client new. We're going to make task. I'm just going to declare it for now because I want to do all the declarations up here. Add a server. So far, so good. Okay, now I'm going to start setting all. This is going to be done in asynchronous mode. So now I'm going to define all of my callbacks. I'm going to set the complete callback, which is going to get the task data. And they all have to return Gearman success, otherwise the client goes bonkers because, again, remember, you're really living in C land. And if you don't return success, then the client object goes haywire. So we got the complete packet, we've got the data packet, we've got the warning packet. Those all have data attached to them. And we have the fail packet. The fail packet doesn't return data. At least I don't think it returns data. So instead, I'm calling the function in. You can see the type that you get in these functions is a Gearman access task. So you could look at the man page or search cpan.org page for Gearman access task to see what you get in there. But I think I covered most of it. The last thing you could have is in a status. You could have a numerator and denominator, which are the two parts of the status packet. Now, the task that we get below in the ret task equals client add task, that task is actually the same task object that we're going to get in these functions. And if you save it, there are actually some methods on that you could actually call, like get status, which will return whatever the latest status packet said. There's another one, but I'm blacking out on it. Success as, and is it still running? You could ask if it's returned yet or not. So if you have a lot of these tasks and you need to iterate over it in a place other than the callback, you could figure out what's come back and what has not called back. Right, there's one other callback in Perl XS, and that's set create function. You could actually get a callback that will pass you the task object of any function that was received by the Gearman server and queued to be run. I just didn't add it to the code, but it would, if I did, it would probably look the same as the fail one, where I'd say, okay, I got this new function called function name. And workload. Workload is also a property of the task object. So we're almost at the end. Ret tasks, so we're going to add the two tasks, and in each one we're going to get a list back. The first element is the return code Gearman success or Gearman error, whatever. And the second one is the task object. We're going to add two of those, and then we're going to call client run tasks, which will also take care of blocking and waiting for them to return. There's also a non-blocking way of running the client, so you could run your own loop similar to the one that I did in the server. The syntax is fairly similar, and a bit of Googling will get you guys going. A more sophisticated client outlook. So we ran it. You could see that in this one, since I had this nice little print, whatever type it was, we can see what's what. We have the two status packets with the numerator and the denominator, the complete with the data, and then the warning and data from the uh-oh function, the warning uh-oh, and then data it broke, and then fail uh-oh. I think that's it. Any questions? Yeah, that's it. Questions? No. Yes. Was I that good or that bad?
I have tons of questions. You can just stop me.
Okay.
First of all, how would you differentiate it from, let's say, a queuing server?
It is kind of a queuing server.
I mean,
it is a queuing server. There's no scheduling on it. Gearman does not support scheduling. There have been every month or two, someone will ask, "Can you add scheduling?" And I think that the primary author now, Brian Aker, is on the verge of adding scheduling just because there are so many requests, and someone's eventually going to write a patch. I'm actually against scheduling. When I had to write my own, I wrote it with scheduling because I needed scheduling. But having worked with Gearman for a while, I like using Brian's answer, which is that Gearman is just a protocol. It's not about scheduling. If you want a scheduler, then write your own scheduler that'll add or add tasks or remove tasks or whatever when they need to happen. Other than that, it is a queuing system. As a matter of fact, when I wrote my own in Perl, we called it async queues or asynchronous queues.
How robust is that? Let's say the worker crashes. How does it
You add another worker. You have tons of them. They're disposable. You could add them. You could remove them. You can do whatever you want. You have all these timeouts, and these timeouts help. The server will kind of figure who's listening. If someone doesn't answer in enough time, it'll send it to the next worker. That's actually how it works. When workers register, when workers call register function on the server just kind of adds them to a list. And then when requests come in, it just adds it sends it to the next available worker.
No, but maybe I didn't understand something. That you have to start the Perl script, which is the worker. Let's say it crashed.
Okay,
Who is responsible for restarting?
you are.
So
You
there
are.
needs to be another layer on each node, on each server.
It could be.
Or
How
do you usually do it?
there are two ways that I've done it. You can add more machines as redundancy. That's option one. And option two is you can have something, a watchdog or something that'll restart the script. Gearman, the PHP framework that I mentioned earlier, Gearman Manager, I'm pretty sure actually has some sort of management for the worker and the client. But Gearman itself isn't about that. It's just about getting the jobs from the client to the workers and the response back to the client. That was two. That wasn't a lot.
For example, how do you debug jobs? How can you see? You mentioned
The
that
same way you debug anything, it's Perl. So you could run this in the Perl debug. I've run workers under the Perl debug. I do Perl -d worker, set a breakpoint.
No, what I meant is you mentioned that you used uppercase and lowercase and it got stuck and you didn't know what.
So there's a syntax. So there's a administrative protocol that you could use on the server. I think there are only like 2 or 3 real functions that I have, but the 2 functions that you're going to use a lot if you're administering this is status, which gives you a list of all the functions that it knows about, either registered by a worker or requested. And next to each one, it'll tell you how many workers are dealing with it now, how many workers are idling and are ready to deal with this, and how many requests are there right now in the server. That last number includes the ones that are actually being run now. And then there's a workers request, which will give you information about every worker connected to it and what functions that worker has registered. And you can identify your workers and you could identify your jobs, and there are some more advanced stuff. People, where are we going from here? We're either going home, going to a pub, or sitting around and talking. So, yeah, I don't mind.
Again.
Spaghetti.